Assalamualaikum and hello everyone. In this video, we're going to learn about the physical properties of carboxylic acid, which we're going to look at the boiling point and the solubility in water. Okay, so first let's look for the boiling point. Okay, carboxylic acid is a polar molecule and can form hydrogen bond. Okay, why? Sebab adanya the presence yang OH ni lah. Lepas tu adanya lone pair pada your oxygen itself here. Okay, so dia sama juga dengan alkohol. Alkohol pun can form hydrogen bond. But what is the difference? So kalau between the carboxylic acid ni, we could form dimer. Sebab adanya kita akan form, contohnya from our oxygen ni, the lone pair akan form hydrogen bond dengan with our hydrogen here. Yang sini pula pun sama juga. Hydrogen ni can form hydrogen bonding with the lone pair on the oxygen here. So apa yang beza dia? Carboxylic acid could form dimer through hydrogen ni or hydrogen bonding. So what happened here is that the carboxylic acid could form more hydrogen bond than alcohol. So bila dia form more hydrogen bond than alcohol, so it is a stronger lah. It has a stronger force. Okay. So now let's look for the comparison. So kita dah belajar banyak dah kan. So yang ini kita tambah lagi. So sepatutnya you should be familiar with these notes. Yang ini sebenarnya sama juga dengan apa yang ada dalam our nota of chapter 15. Tapi I'm gonna copy paste it here. Okay. Go back to our chapter 17. Okay. So we have learned there's actually three of our intermolecular force. Okay, remember, first adalah London force, specifically untuk non-polar saja. Dipole is only for polar, and hydrogen bonding it must be fluorine. Oxygen dengan nitrogen must be bonded to hydrogen. Okay, so alkane is only London force. Haloalkane is a London force as well as and then dia ada dipole force. Okay, kenapa haloalkane ni is not hydrogen bonding? Sebab contohnya kan, kalau contohnya fluorine dia is not attached to carbon, dia is actually bonded to your carbon. So lagipun halogen usually we gonna learn bromine dengan chlorine kan. Fluorine jarang kita tengok. Okay, so alcohol we have hydrogen bonding. Okay, so how to compare? Carboxylic acid pun kita belajar juga hydrogen bonding. But we know it's actually for this four different molecule ni, kelas ni ada different factor lah. So for carboxylic acid, ada special dia is that it could form dimer. So bila dia could form dimer, sebenarnya it can form more hydrogen bond than alcohol. So what will happen? The intermolecular force between the carboxylic acid itself tu is stronger lah. So sekarang ni kita nak tengok the increasing order of boiling point. Previously we have learned alkane is the weakest, followed by haloalkane, and alcohol is the strongest. But right now we have learned a new thing, which is our carboxylic acid. It could form hydrogen bonding as well, tapi specialnya dia, they could form dimer through hydrogen bonding. So it is stronger than alcohol. So maknanya the strongest one between these is actually our carboxylic acid. Okay, so that is if we compare the boiling point between different classes of compound. How about when we compare it's between the carboxylic acid itself? So for a given molecule, first thing first, what we're going to look at, the most prominent factor adalah number of COOH group. Okay, so the higher the number of your carboxyl group ni, what would happen? You can form more dimer through the hydrogen bond. So what happen? You could form more hydrogen bond, so you have a stronger intermolecular force. So the more force is needed to overcome, so that's why we will have a higher boiling point. Okay, so just to summarize, maknanya higher COOH, higher lah our boiling point. Okay, next, if we have the same number of COH group, but then what's the difference? It's actually molecular mass. Molecular mass ni, the difference tu is actually what you're going to be focusing on is actually pada number of carbon. Okay, sebab kalau hydrogen, dia punya molecular mass is only 1. Carbon is 12. Okay, so that's why we have to look at kalau molecular mass, different carbon. So the higher the molecular mass, okay, maknanya the stronger lah our intermolecular force. Kalau between carbon and hydrogen tu is actually our London force. So bila dia jadi stronger, more energy is needed to overcome, hence we will have higher boiling point. Okay, so sama juga kat sini. Then the higher the number of carbon, boiling point kita akan tinggi. And last but not least is we're going to look at the surface area. Surface area tu kita kena tengok pada substituent. So for example here carboxylic acid, mother want to write down. So ada 5 kan. 1, 2, 3, 4 ni. Okay, 1, 2, 3. Okay. So kalau kamu tengok, if you look for your carboxylic acid, all of it has the same number of your carboxyl, and then have the same number of carbon. Next is going to look at the surface area. Surface area tu kena tengok number of substituent lah, ataupun in this note I write down the branch. So what happen, the higher the number of branch, maknanya surface area tu akan jadi low. So bila dia jadi low surface area, less energy is needed to overcome the force. So what will happen? We will have to lower the boiling point. The higher the number of branch ni sama juga dengan substituent lah. Okay, so yang ini dia berbeza sikit. Kalau dekat sini substituent dia attached to lagi rendah, BP dia akan lebih BP dia will be lower. So yang ini pun I did not do any explanation banyak sangat, sebab ni pun kita dah previously tengok dalam alcohol jugalah, this part. Okay, so now let's look for the example itself. So example dia kata arrange the following compound in order of increasing boiling point. So first kita kena tengok it's either what's the difference, different class ataupun different color between the carboxylic itself, between carboxylic acid itself. We have to look at these 3 factors. So here we have example A, 1, 2, 3, 4 ni. Okay, so kita tengok semuanya adalah carboxylic acid, and then we also, all of it only has one COOH. So what's the factor that we're going to look at? It's actually the molecular mass. Ethanoic acid ni ada 2 carbon, metanoic 1, pentanoic 5, propanoic 3 carbon. So yang ini, I believe you could do it yourself. Arrange it in order of increasing boiling point. So example B dengan C pun I believe you could do it yourself. First and foremost, look, if it has different class, we're going to look at this factor. Kalau sama saja carboxylic acid, we're going to look at these 3 factors. Okay, that is for your boiling point. Now let's look for the solubility. Okay, solubility is actually, kita akan tengok the ability of the compound to form hydrogen bond with water lah. Okay, so carbon 1 until 5 is completely soluble because the ability of it to form hydrogen bond with water molecule. Again, hydrogen bond nak dengan fluorine hydrogen, oxygen hydrogen, nitrogen hydrogen. Okay, yang ini yang kamu kena ingat, in the presence of water, the carboxylic acid do not dimerize. Instead, they form hydrogen bond with water. Yang kita kata dimer tu, bila kita nak compare carboxylic acid, nak compare the boiling point, is it actually between the carboxylic acid and the carboxylic acid itself. Okay, so kalau carboxylic acid with water, we're going to form hydrogen bond. So maknanya, between our lone pair dengan oksigen ni, dengan our hydrogen, will form our hydrogen bond. Tapi that is actually for the case of carbon 1 until 5. Kalau carbon more than that, is actually insoluble in water. Okay, why? Sebab your carbon tu is actually R ni is hydrophobic part. So they cannot form hydrogen bond with water. Again, kita kata solubility ni is actually ability to form hydrogen bond with water kan. Kalau dah carbon dah banyak, it cannot form the hydrogen bond, hence it is insoluble. The same goes for aromatic carboxylic acid. Sebab kalau aromatic, the carbon dia adalah 6. That is the minimum lah. Kalau contohnya kita ada banyak lagi substituent, we have more than that. So it is insoluble. But then the dicarboxylic acids are relatively more soluble. Okay, why? Sebab when we have more of our COOH, maknanya we can form more hydrogen bond. Hence, it is more soluble. Okay, so that's the last of solubility. Simple sahaja.